Lesson 35 today. Lesson 35. Sorry. It's 36. You're all right. Lesson 36. Okay, guys. Angles greater than 360 degrees. Here we go. Guys, be nice. We are recording. We are recording, yes. Okay, so we've already talked about this actually. When we did that half a worksheet that I had you guys find angles that were coterminal, at the same time we did the reference angles, we're basically now talking about coterminal angles. And remember, coterminal angles are angles that terminate in the same spot. So we always have our initial side, and that was bad, and our terminating side. So we have our initial side and terminating side. And our angles always open upwards, correct? Okay. So what we're now going to have is that an angle is not going to stop when it gets to here. It's now going to continue around an extra time. Or it continues on even more and does it again. Or does it again. What it means is that you guys hopefully agree that if you're facing the front of the room and you stand up and you turn around, you face the same direction. If I go around again, I'm still facing the same direction, but they all differ by 360 or 360 degrees. We call that coterminal angles. Coterminal angles. Coterminal angles, guys, differ by 360 degrees. Whether I add to it or subtract from it. Okay? So, if I come over here and I say 45 degrees, find me a positive and negative coterminal angle. You guys are hopefully saying, not a problem, Mr. Konchak. All I need to do is add 360. And I'd be at where? 405. And take 45 and, if I want a negative one, subtract 360. And I'd be at negative 315. Those three angles, 405, negative 315, and 45, are all coterminal. They stop at the exact same spot. Now remember, negative angles go down or clockwise, positive goes counterclockwise or up. Okay? Now, we could get a little trickier on us, and we could say, what happens if I had an angle of 1025 degrees? Find me a positive and coterminal angle to that. Well, you can go back to your idea that if I want a positive coterminal angle, I just got to add 360, right? So if I add 360 to this, I would end up with 1,385. That's positive. It's coterminal. I'm happy. What about a negative coterminal angle? Oh, so I got to probably subtract 360 from this instead, right? What happens when I subtract 360? What do I get? 665. Wait a minute. Is that negative? That's positive. So actually, in this particular problem, I just found another positive coterminal angle. That's not good enough for me. So I need to subtract 360 again. I end up getting 3 0.05. Darn, it just came out to a positive answer again. So I'm going to do it again. And so now I end up with a negative 55. We now have our negative coterminal angle. But along the way, I found several other coterminal angles that were all in the same spot. They're all coterminal. Now, the reason I chose that to be so large like that, so we had to do it several times, is because eventually we're going to have to take the sine, cosine, and tangent of these things, and you're going to want to be able to do this. You're going to want to be able to add or subtract 360 from our number so we can find a coterminal angle that is between 0 and 360 most of the time. Now generally, we like the positive angles, but it doesn't have to be, because if I asked you the sine of negative 45, hopefully you recognize that it's the same thing as sine of 45, but it's negative. Why? Why is the sine of negative 45 the same thing as negative sine of 45? What would be some reasonings behind that? Think of where negative 45 is.
Just the same spot, just 360 degrees apart.
They're the same spot, they're not coterminal, because they actually differ by 90, not 360. True? This is going to be on the bottom right. This is fourth quadrant. But what would be the reference angle to negative 45? 45. 45, sine of 45 and sine of negative 45 have both the same reference angle. Now we have to go back to that reference angle thing. What was the reference angle again? Reference angles are the distance back to the nearest x-axis. Sometimes we call it the leftovers even. And so, 45 degrees, no matter if I'm in fourth or first quadrant, it's 45. So there's your connection, why they end up being pretty close to the same thing. But why is it sine of negative 45 equal to negative sine of 45? Why all of a sudden does this negative come out front? Why is it even there? Which quadrant are we in? 4. Sine is what in quadrant 4? Negative. Remember, reference angles are always referencing the first quadrant. They're always positive. I need to assign negatives according to all students. Take calculus. So we need to know that today. You also better have this in your notes. Well, why is that a 40?
Because you wrote it like that.
Because I wrote it that way. 30, 60, 90 triangle. And a 45, 45, 90. 1, 1. And 1, 2. Square root of 3. Those three pieces are going to be needed for today's lesson. Those things you all have been told before. So let's put all this together. This whole idea here, and our next stuff that we're going to do asks you to do this. Okay, now that we got past that ruckus, this is what it all comes down to. Okay, it comes down to evaluating the sums and differences of different trig functions. So now they're going to have you, instead of just evaluating what the cosine of 135 is and leave it, they're now going to have you do two different functions at two different angles, maybe even the same angle, and then at the end, put them together. We've done this with one of these already. We just never done it with more than one at one spot. Okay. Okay, we're starting to get there. Okay. Guys, this one deals with reference angles and no coterminal angles are needed. And so what we need to do here is say, hey, cosine of 135. Let's graph that quickly.
Oh my God. Oh no.
Back after the internet dropped here. Guys, we stop and think. Where is 135? 135 is in the second quadrant. 135 has a reference angle of 45. So that means that cosine of 135 is the same thing as cosine of 45. Or wait, or is it? It's in second quadrant. Cosine in second quadrant is negative. So it actually is a negative cosine of 45. Tangent of 330. 330 is in the fourth quadrant and has a reference angle of 30. Tangent in the fourth quadrant is negative. So this is minus tangent of 30. So we get negative tangent of 30. Overall, now we have 45 and 30 as our angles. That's one of our two reference triangles. It makes it so we can actually evaluate. What is the cosine of 45? Cosine of 45 would be 1 over the square root of 2 or square root of 2 over 2 minus the tangent of 30. And the tangent of 30 happens to be square root of 3 over 3, because normally it's 1 over the square root of 3. Or was that correct? Tangent of 30 is 1 over square root of 3, correct. It's on our circles, triangles. And now, we just need to evaluate. That makes this a negative square root of 2 over 2 minus the square root of 3 over 3. Put it together. They don't have common denominators, so we better make it a common denominator by multiplying the top and bottom by 3 and 3 on this one, and 2 and 2 here. So it becomes a negative 3 square root 2 over 6 minus 2 square root 3 over 6. Put it together, we get, they're not like terms, so I can't group them the same. And there's our answer. That's the exact answer. There's no calculators being used on any of this. The only time I would expect, or not expect, but allow a calculator to be used on something like this is if you didn't remember what the reference angle could be. So you had to use your calculator to figure that out, which I hope you wouldn't have to. So our next problem is the cosine of 570 degrees plus sine of negative 765 degrees. So remember, what we're trying to do is use the fact that we have coterminal angles that will make the angle between 0 and 360, so we can find its reference angle, which is one of our reference triangles, which we can evaluate and then put together. So cosine of 570, a coterminal angle to that would be probably subtract 360, correct? So that'd be the cosine of 210 plus sine, that's a negative 765, so probably add 360. So let's add 360, and you end up with negative 405. Is that a nice angle yet? Is that between 0 and 360 in a way? No. So we probably should add another 360 to that. So this would be the sine of negative 45. And we kind of talked about that one earlier. I'm going to bring cosine of 210 down. Now, can I actually be at a point where I could find reference angles?
Yes.
Yeah. Let's graph 210. 210 would be somewhere in the third quadrant. What would the reference angle be? 30. Hopefully you guys are finding that easier now than, say, like 4 or 5 lessons ago where you guys were just learning about it. I think even before, I think that was before on our final, right? We had to do stuff like this. And you guys were having a hard time with this idea of what a reference angle was. Now you guys are starting to spit them out. It's awesome. Now, what about negative 45? What's that reference angle? 45. So that means it's the cosine of 30, or it's actually negative because it's in the third quadrant. Sine down below is also, so it's minus sine 45. And then now you can pull out your reference triangles and evaluate. What's the cosine of 30? It's a negative of square root of 3 over 2 minus sine of 45.
1 over root 2 over 1.
Square root of 2 over 2. Hey, we like this, guys. It has common denominators already. So, when we come over here, we end up saying, hey, that's a negative square root of 3 over 2 minus the square root of 2 over 2, which ends up making it all over 2, and we're happy again. Homework is on page 259, 6 through 7, 13, 24 through 25.